Okay, here's part 2 of test 1, question 15 of 30. So this is the parameters IPT. It says change the diameter of the master hole to 8.165, locate it, and what's the next parameter name in the table. Okay, so how do we figure out what the master hole is? Well, what they're talking about with the master hole is the hole that they generated the circular pattern from. So if you see the circular pattern, you could actually double click in that if you wanted to see if there was multiple holes and you weren't sure which one it was. If you double click the circular pattern, the one that they're patterning will be highlighted. Okay, so you know, and that's all you need to open the circular pattern for. You cancel it. Now that's hole 1. So we double click hole 1 and change its diameter to 8.165. Now it will allow us to identify it and just say OK. And now we need to locate the parameter name of the master hole. So what we'll do is we'll go up here to the FX, go to parameters. If it's not on your quick access toolbar up here, then you would have to go to to manage parameters. And I'm going to click it up there. And then we just have to go down through these equations until we find 8.165. And the parameter name for the master hole is D14. And full disclosure, I put D14 in and couldn't figure out why it wouldn't be correct. And then when it said it was D19, I looked down here and then I said, oh, what is the next parameter name? So it's the next one after D14 is D19. You could do Control C on that, click over here, Control V. I would close that, say next, and D19 is the answer. Okay, what type of dimension controls geometry? A driving dimension, not a driven dimension. Driven dimensions are the one that's in parentheses. So just know that who's in control of the car? The driver, the person driving. The driven dimension, they're just being driven around. Their number changes based on this number. So driving dimension. Okay, shared sketches, share the sketch for the circular cutout. There we go, Inventor crash. When Inventor crashes like that, restart associated application. I thought by closing all those dialog boxes I could limit it, and I have limited it quite a bit, but not quite enough, I guess. And we wait for it to restart. Now, if it comes up like this without your ribbon, without your tabs and your proper ribbon, then you have to come down here and reset the current file. And it reloads the file, and now you've got your ribbon with your modeling and your sketch. Okay, now the first thing I always do, if I need to, is flip a part around so it looks kind of similar on my screen to the way it looks on their screen to help me understand. Now what they want us to make a little circular cutout down here to get the area of the tiled surface. So here's our circular cutout. Now it looks like they might have 3 of them in here. To make it look just like this, we'd have to do it a couple of times. But we're only worried about this end one. Okay, they're not asking for the volume of the part, the mass of the part, the CG of the part. All they need is that surface area. So we can take some shortcuts here, but So they want us to share the sketch. So what's making that circular cutout? We'll just hover up over, there it is. Hover over these extrusions until that green one lights up. Click the plus next to it. That's sketch 6. We right click on it and we share the sketch. Now we can use that sketch to do another extrude. Because you can't, the sketch is consumed on the first extrude, you got to share it to use it again. Okay, extrude. We only need to extrude the bottom half of this. Okay, and we're not doing a join, we are doing a cut, which is going to run it through there. Well, how far back does that go? Well, we don't need an actual dimension because we can say 2. We can use this 2 thing here, click 2, that face, and it'll cut all the way to that back face. Now we could just leave it like that with all that stuff cut out because all we care about is that surface area. But just so you'll see how to do this, I'm just going to run it between these two. So just to run it between these two, I need to, instead of starting at my sketch plane here, I need to start from a different place. So I'm going to go from, I'm going to click up here, and I'm going to select this plane, which I can select right through my object. And I'm just going to go from here to there. And I'm going to say, okay. Ignore that, doesn't matter because we're looking for the surface area there. Right click in space, measure, select. And we'll go 3 places on this one. It rounds down, so that should be good. Control C, click, Control V. 3 decimal places, I'll say done. Next. Oh, did I put the perimeter in again? Dang it. Oh, okay. Don't do what I say, not what I do. Okay. So, again, I'm going to cheat. I'm just going to take that extension, that extrusion right there, and go to there with it. It's going to give me the same answer. Right click, measure, click. Yeah. Okay, so this is gonna round up. Okay. So I'm gonna do Control C, Control V, and make that to 1. Next. Yes. Next. Okay, this one's pretty easy. We edit the sketch. You got to edit the sketch to do all this. Top, moving clockwise. The clock goes around to the right. Horizontal or vertical constraint. So horizontal is this one. Vertical is this one. Horizontal again. And that's going to give us this length. So on this one, I can right click. And I'm still in sketch, so now they, for some reason in sketch, measures down here. Now I can measure that, and I get that length. Okay, 13653, so that's going to round up. Control C, Control V, 137. Next, and that's the correct answer. Okay, circular pattern. Or rectangular pattern. Okay. Haven't done many rectangular patterns, so this might be new. Now they want the surface area of the tiled surface, not, and it wouldn't matter if they wanted mass. As long as they don't want CG, it really doesn't matter where these holes are, as long as you get 5 times 3 is 15. As long as you get 15 holes in this surface, that surface area is going to stay the same, and the mass is going to stay the same. The center of gravity will change, but we know that going in. So how do we do this? Rectangular pattern. So click rectangular pattern up here. The feature we're going to do, you can try and select it here again. Again, you don't want to get the whole part. I like to come over here and just select the whole. Okay. So now, how do I make a pattern going across? Well, the direction 1, I click the arrow and pick a line. Or generally I like to do a line to tell it which way I want that thing to go. And I could do this line first and go this way first and then that way, or I can go this way and then that way. So I'm going to pick this long line here. And that line's going in the wrong direction, so I just flip the direction. Boom, it's going up. I need 1, 2, 3, 4, 5. I need 5 of those. 1 inch spacing. Again, the spacing wouldn't matter. So I've got 5 going this way. How do I get them going across? That's direction 2. Click direction 2, select a line going across, and it's going the correct direction. So I need 3 of those. So I've got 5 by 3, looking good. Okay, right click, measure, surface. Let's try and get the area instead of the perimeter. So 2, 6, this will be 2, 6, 4. Control C, Control V. I'm gonna take that up to 4. Say done. Next. And that's the right answer. I really should go in and see how to fix that so that you guys don't have to deal with it, but you might have to anyway. We'll see. Next question. Okay, change the small hole in the plate to counterbore. Dimension is 1 inch in diameter, 0.125 in depth. Surface area of the plate. Okay, another one. They want the surface area. We really, the small hole is hole 2. We could just change the diameter of that hole to 1 inch, and it would take away the same amount of surface area instead of doing a counterbore and making the counterbore 1 inch. See, if it goes 0.25 deep, it goes through the whole thing. If we make it 0.125 deep, either way gives you the same answer. So that's your whole counterbore. As long as it takes 1 inch round out of that surface, right click, measure, surface area, not perimeter. Okay, that rounds down to that number. Control C, Control V, done, and next. Yay, correct answer. Next, shell. Okay, so we've got this block. They want it shelled out and chamfered. But you've got to do your chamfer first. They show it first, do it first. If you don't do the chamfer first, then you won't get a constant thickness around these edges, and that chamfer on the inside won't be the right size. If you shell it and then chamfer the inside 0.5 and then chamfer the outside 0.5, you will not get the right answer. So you have to chamfer first. And when you chamfer, when you click the corners, you don't have to rotate your part. You can click right through it. Type in 0.5 because it was already highlighted. Say, okay, you're done. We go up here, click on shell. We want the top removed, so we click that top surface removed. 0.125 thickness. I should just typed it, 0.125 thickness. Okay. Surface area of the inside chamfer, which is that one. Right click and space, measure, select that. Area 3, this is going to round up. I'm going to take all 4 of those just to help remind me. Control C, click Control V. So that's not 316, that, or 136. That's 132. Done. Next. Hey, got that one right. Okay, open extrude surface. Surface model shown in the image. Extrude it to 4 inches. What's the surface area? And they want the area of the whole thing. And this is where things can get a little bit tricky because we're just going to extrude that line 4. Say okay. And that gives us a surface. Now they want the area of the whole thing, but if you look in iProperties, it doesn't have any area. So this is one case where like iProperties for the whole thing doesn't work, because if you update, it's got no thickness. That surface has no thickness or anything. So this is a case where the one case we have to use the measure. You click the surface and it gives you the area. 3254. So that's going to round down. So 325. Control C is good. Click in here. Control V. Done. Next. Next. Yay, got it right. Next. What type of constraint will be used to constrain the nut to the bolt? Okay, whenever you're using round things like this, always insert. Always insert. Because if you've made it, you have to do two constraints. Insert does them both at the same time. Okay. Next. Got it right. Okay, now this one is a little tricky. Assume if we're going to mate this down, okay, we're going to mate this to that plane. Then how much can you move it? If you flop that down and mate it. Well, if it's mated to that surface, you can't pick it up off of that surface. You can slide it so you can't pick it up in Y. So you can't transition, cannot, and they're asking cannot be made. So you cannot lift it, you can't move it in the Y-axis. You can move it in Z and you can move it in X, but you can't move it in Y. Now you can rotate it around Y, but then you can't rotate it around X or Z. So you can't rotate about the Z, and you can't rotate about the X. Okay, and look at that, it let me pick all three of those. I think it used to not let you do that. Let's see if I got the right answer. Next. Hey, how about that? Okay, next question. Okay, what type of Inventor file is used to show an exploded assembly view? You guys have made one of these. It's not an IPT. That's what you put together to make your assembly. It's not a drawing file. It's not the final file. You put the file on the drawing, like we did with the train. We took our parts, we created an assembly, and then from the assembly, we created the presentation file, which was the exploded view, and then we placed the exploded view on the IDW. So a presentation file, an exploded view is an IPN. Next. Yay. Okay. A sketch cannot be used again after it has been consumed. They want you to say true. In reality, it can be used again, but you have to share it. Either share it or make it visible. But they want you to say that it cannot be used again. But we just did it. We just shared the sketch on whatever that question was. I don't remember. But we shared the sketch and reused it. So you can use it again, but you have to share it first or make it visible. But we'll say true anyway. And oops, well, they've changed it. Okay. So, oh, yes. So they have changed it. Share sketch function in the context menu. So they've updated this question. So false. A sketch can be used again, but you have to share it. Next. Next. Okay, true or false? A feature that has dependent features cannot be suppressed. No, it can be suppressed, but all its dependent features will be suppressed as well. So a feature that has dependent features can be suppressed. So this question is false. That statement is false. Next. What tool would be used to apply rounded corners? Now it's kind of hard to see that those corners are rounded. You would fillet those two corners. Chamfer makes them square. Fillet makes them round. There is no bevel command. Fillet. section view. And this one on this test 2, there's some confusion here because they want a projected view. That's this one, but a section view has section lines. So it's option 1 is the section view. How are suppressed features indicated in the model viewer? How are they indicated? So let's create a new part. If we simply we started a sketch, a circle, and extruded it, if we suppress that feature, suppress features, it is grayed out and has a line through it. Next, grayed out with a line through it. And that wraps it up. We answered all the questions. Yeah, I did not get a perfect score on this one, but we went back and fixed it. So we'll go next. Want to finish. Next. And it gives us a grade. Yay, we passed. So hopefully this will help you guys pass. Again, you don't need 1,000. Certification exam, you will only need a 700. But to qualify to take the certification exam, you need to be getting 850s on your GMetrix test, or a composite, an average at least of 850s. So if you got some 900s, maybe you can get it by with an 833 or something. Anyway, hopefully this helps.